This is the tutorial video of PIV experiment about pump and laser system operation process. This video includes details of the experimental system, as well as instructions on how to operate the pump and laser system. Now, we will start with the circulation pump. We can see the loop, water is discharged from the circulation pump to the heat exchanger. There are two paths in the heat exchanger, one path goes to the PIV, and the other path returns to the pump. When the water goes back to the pump, it absorbs heat and plays a role in cooling or heating the PIV. To operate this pump, you need to fill the pump bath with water up to about 80%. Turn on the pump power. When the blue lead lights up, press the round button followed by the enter button in sequence to start the pump. Then, you can see the water being discharged from the pump. Leaks can occur anytime and anywhere, and Teflon tape can be very useful in such cases. Our default setting is 21.8 degrees Celsius, but you can easily change it to a different temperature using the intuitive button controls. And you can also check the current temperature on the display. Now, let's start the main pump. Turn on the power button. After starting the pump, you can adjust the flow rate using the flow meter. When operating at a high flow rate, be careful to prevent the channel from bursting due to fluid pressure. The water stored in the reservoir is transported to the channel by the pump's pressure. The reservoir is filled with degassed water, as explained in the degassing process. The seeding particles are added by measuring 0.25 gram per liter, using a scale. The tubes are connected using one-touch fittings, making disassembly and assembly easily. It is recommended to use slightly flexible tubing to connect the inlet and outlet ports with the tubes. The fluid follows a circulation system where it passes through the channel and then returns to the reservoir. Before starting the experiment, make sure the reservoir valve is open. Otherwise, the internal pressure in the channel may increase, posing a risk of bursting. When the pump is running, tilt the channel to release any trapped air inside. After the experiment, tilt the channel in the opposite direction to drain the remaining water inside. There are two thermometers and one heater, insert them into the pin fin and copper block, respectively. The channel can also be positioned horizontally for observation from above, and the process is the same as the vertical method. When turning on the heater, first switch on the heater power, then adjust the temperature using the buttons. The set temperature is displayed in green, while the current temperature is shown in red. The temperature can be obtained based on the desired thermal conductivity. When ending the experiment, turn off the heater and wait at least 5 minutes for the pin fin to cool down. This step is crucial to prevent damage caused by channel overheating. Now that the explanation of the channel system is complete, let's move on to the camera setup. We will insert nuts into the aluminum profile and set up the camera mount. Now we will connect the synchronizer to the camera. It can be easily connected by matching the terminal shapes. The camera magnification and its distance from the channel are determined with running the laser preview. Now, let's start the laser. Turn off the light and close the door to create a dark environment. However, we will conduct the experiment in a bright environment for video recording. Open the node on the laser generator and fill it with coolant. Regular water can also be used as the coolant. Then, turn on the laser power. Turn on the synchronizer. Turn the key to the right. Press the button to activate the laser. Wait for 10 seconds until all indicators turn green. Then, press the green button to open the shutter. Listen for the distinct sound. Create a folder following the naming convention. Now, we turn on the Dantec Dynamics software to run the preview. Then, click the Data Acquisition mode. Now we will run the preview mode. But make sure to check the synchronizer is activated. And these two numbers must always be positive. Make a new database. Select the folder we just created. Name it according to the naming convention, and save it. Now click the preview button. You can hear the sound of the laser operating. Now, adjust the position of the channel while moving it, so that the laser sheet illuminates the region of interest. There is nothing shown on the screen, because the camera has not been adjusted yet. Now, let's adjust the camera. Move the camera back and forth to adjust the frame, so that the region of interest fills the screen. At this point, adjust the height of the stand to level the camera. Now, adjust the magnificent factor to set the proper zoom level. Or, you can back calculate it based on the flow velocity. Refer to the PIV file for details. You can adjust the contrast using the global color map function. Check for contamination and bubbles, as both can cause critical noise issues in PIV. If it's an acrylic issue, disassemble and clean it. If it's a bubble issue, slightly increase the flow rate, and wait until the bubbles move and disappear. The explanation of the pump and laser system is now complete. In the next video, we will cover actual data collection and the software.